Let's explore the power of iteration in JavaScript. We will cover the core concepts like iteration protocols, how to create custom iterables, the use of generator functions, and asynchronous iteration techniques. These concepts are crucial for efficiently handling data and creating more manageable code. The Symbol.iterator is a built-in symbol that defines how an object should be iterated. When an object implements this protocol, it becomes iterable, meaning it can be used with for loops and also works with the spread operator. The example code shows a basic implementation of the iterator protocol within an object. Here we see how to use iterables in practice. The top example shows how a for loop can be used to iterate over an iterable object. In the bottom example, we see how the spread operator can be used to create an array from an iterable, and how destructuring can be used to extract values from the iterable. These techniques make it easier to work with data in JavaScript. Let's learn how to implement custom iterables. To create a custom iterable, we need to implement the iterator protocol. This involves creating a method using Symbol.iterator that returns an object with the next method. The next method should return a value and a done flag indicating whether there are more values to iterate through. The code example demonstrates creating a range iterable using a class. Now let's look at real-world examples of custom iterables. On the left, we have a paginated data iterator which takes a list of items and a page size, and returns an iterator that provides chunks of the items based on the page size. On the right, we have a DOM tree iterator that can be used to traverse a DOM tree. These are examples of the power of implementing custom iterables. Let's discuss generator functions. Generator functions are special functions that use the function asterisk syntax. They yield values one at a time, maintaining their state between calls. Crucially, generator functions automatically implement the iterator protocol, making it easier to create iterables. The example demonstrates how a basic generator function operates and how to use it. Here we'll explore some advanced generator patterns. The first example shows how to create a generator that takes input using the yield keyword. The second example demonstrates how to create an infinite sequence generator, which can be used to generate an infinite series of values, such as the Fibonacci sequence. This highlights the flexibility of generators. Let's dive into async iterables and generators. Async iterables use the Symbol.async iterator, and the iterator's next method returns a promise. You must use the for await of loop to iterate over an async iterable. Async generators use async function asterisk syntax and can yield promises directly. This allows for elegant handling of asynchronous operations within iteration. Here are some real-world examples of using async iterables. On the left, we see a DataStream class that simulates fetching data in chunks over time using setTimeout. On the right, we have a paginated API class that fetches data from an API in paginated form using a while loop and yields the items. These examples show the usefulness of asynchronous iteration in JavaScript. Finally, let's cover some best practices and key takeaways regarding iterables and generators. When designing your iterators, make sure they are simple and focused, and always follow the single responsibility principle. Also, be careful when dealing with infinite sequences, as they might lead to memory issues. Use generators for lazy evaluation. Avoid storing entire sequences in memory. When deciding which type of iterator to use, remember that iterables are for finite collections, generators are for computed sequences, async iterators are for streaming, and async generators are for paginated APIs. Keep these things in mind when you implement your iterators. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.